In 6.3, we're going to continue what we started in 6.2. We're going to look at a couple of applications of the normal distribution and see how it is that any data that has a normal distribution can be converted over to a standard normal distribution. And as we go through this, we've got some examples set up for you, and then we'll jump over to Excel and use Excel to answer several questions about normal distributions. So let's look at the PowerPoint slides first, and then we'll come back and look at Excel. We start here with basic concept is that we don't have to be given the standard normal distribution where the mean is 0 and the standard deviation is 1. Any data that has a normal distribution can be converted over to a standard normal distribution by using an equation that's pretty familiar to us by now, using this. Anytime you're given an x value, if you know the mean and the standard deviation, you can find the z-score for that particular x value. And this is the way in which we can take any normal distribution and convert it over to a standard normal distribution with a mean of 0 or standard deviation of 1, and use z-scores instead of the original x value. Now with our formulas that we have in Excel, it's not so important that we convert everything over to from x to z, because we have a way of letting Excel do that for us. But even so, we want to make sure you understand how that's done, because you may not always have access to Excel, and so it's just good to know how it is to convert from x values to z-score. Here's a visual. You can have a normal distribution and be given a mu and an x. As long as you know the standard deviation of the normal distribution, you can convert that to standard normal distribution where every x value has a z-score. Everything on the right here, everything on the right is going to have a z-score that's positive. Everything out to the left of the mean is going to have a z-score that is negative, because it's always the x value minus the mean. So anything less than the mean is going to have a z-score that's negative. Just some of the things that I hope you've become accustomed to as I've worked examples on the board. One of the things that always helps is a picture. So when you're finding areas with non-standard normal distribution, it's always good to start with a sketch. And you're going to label the mean and whatever the specific value of x is that you're looking for. And then it's always good to shade the region that you're looking for. Shade the region that represents the desired probability. And we know from Excel, if it's the probability to the left, then Excel's set up to answer that directly. But if it's the probability or the region to the right, then we have to use complement. We're going to have to use 1 minus. And so we've got some examples in this lesson to help you understand and to reinforce some of the things we talked about in the previous section. We're going to be using Excel, but you can always use calculator, or you can use the table in the book. But for the purposes of this class, we'll be illustrating how to use Excel for these calculations. Okay, I'm going to be using these 4 questions, these 4 problems to illustrate how it is that we use Excel to answer questions about the normal distribution. And given that women have a normally distributed height with a mean of 63.8 inches and a standard deviation of 2.6 inches, let's find the percentage of women who have a height of 70 inches or more. And we'll go through and do that here in the PowerPoint. I have that spelled out, but then we're going to jump over to Excel and show how that's done, as well as these other 3 questions. We're going to find the percentage of women who have a height of 60 inches or less, the percentage of women who have a height between 62 and 65 inches, and then the height range for the middle 60%. So the middle 60 from the 20th percentile to the 80th percentile. We're going to see how we can use the standard normal distribution and z-score in Excel to calculate the range for the middle 60%. Okay, so just to remind you that last section, we were introduced to these three functions in Excel. The first two are pretty similar. First two return the cumulative probability from the left. In one case, you input the particular x value that you're interested in, the mean and the standard deviation, and then say whether or not the cumulative, in this case, it's going to be true because we're looking at the standard normal distribution. We'll be reminded of that when we go into Excel. Or if instead of having the x, the mean, and the standard deviation, if you convert that over to z-score, which you can do from that equation that you saw back in slide 2, then you can just use norm.s.dist and put in the z instead of these three values. In both cases, these return the cumulative probability from the left. The inverse, looking at it from the other angle, if you know the probability, if you have a desired probability and a mean and a standard deviation, then this will return x. It will return the x value on that standard normal distribution that gives you this desired probability. Okay, let's go to, I was mentioning, we're going to work through all four of these, but for now, let's work through the first one, the percentage of women who have a height of 70 inches or more. It's a good thing to start with the picture. So if we use a normal distribution, has a mean of 63.8, we're looking for 70 inches or more. So the region up here, this arrow's pointing at it here, we want to look at what percentage of the area or what probability there is that a woman selected at random would be in this region having a height of 70 inches or more. If we use norm dist, we would just plug in those values. We would just plug in 70, 63.8, and the standard deviation. We plug all that in, but instead you can also use this formula here to convert it over to z-score. So 70 minus 63.8, that's the particular value of x minus the mean divided by the standard deviation. So a height of 70 inches corresponds to a z-score of 2.38 on the standard normal distribution. Okay, and either you can use a TI calculator, you can use the table in the book, or you can use the norm dist function in Excel or the norm.sdist function, either one, and it would give you the number 0.991344. But I hope you're getting comfortable with the idea that when it returns an area like this, or it returns a percentage, 99.1344%, that is the area to the left. We talk about the cumulative probability from the left. So in this case, since we're looking at the area to the right of 70 inches, we'll need to subtract that from 1. And if you subtract 0.991344 from 1, you get 0.87%. So less than 1% of all women have a height of 70 inches or greater. Okay, because we're shading to the right, and this returns cumulative probability from the left. That's why we have to do 1 minus. Okay. Here are a couple other things that just want to be careful with. Don't confuse z-scores and areas. Z-scores are those distance from the mean along the horizontal scale. Area is talking about the region under the normal curve, that shaded region, which we're going to try and figure out what percentage of the area under the curve is designated by that shaded region. And then make sure that you're aware, are we working to the left or to the right? Depending on which side you're working on, and if you're going above or if you're going below, you have to keep that in mind when you're working with the results from Excel, because it's always going to give you the probability from the left. And so if you're working off of the right side, you're going to have to make sure you subtract from 1 to account for that. It's on the left-hand side of the mean. If you're looking in the lower half, then the z-score is always going to be negative. And then the probabilities are always going to be non-negative, which means they're either positive or 0. They're never going to be negative, so probability is always going to be somewhere between 0 and 1 inclusive. Okay, just keep that in mind. There's some advice to help you in finding values, finding X values when you know the area or you know the probability. This is important to refer to if you don't have Excel at your disposal. But since we do, I'll let you file this away for reference later in cases when you don't have Excel. Here's another example. Here is the case of the height of men. When designing aircraft cabins, what ceiling height will allow 95% of men to stand without bumping their heads? Men's heights are normally distributed with a mean of 69.5 inches and a standard deviation of 2.4 inches. So we want to figure out what height would include 95% of all men, talking about men now, would include 95% of all men when the mean is 69.5 and the standard deviation is 2.4. Okay, so we're looking for the area to the left. If you're catching on to how Excel works, you know that we shouldn't have to do any finagling with the results that we get from using our Excel function, since this is already the cumulative probability from the left. So we can calculate that. If we're you can use the table in the book to figure out that if we're looking for 95%, that Z is going to be 1.645. How would we find that? Well, we would use the norm inverse function in Excel. The norm inverse function in Excel would give us that Z is equal to 1.645. Okay. And with a mean of 69.5 and a standard deviation of 2.4, if you take the equation x minus mu divided by standard deviation equals Z, that equation back at the beginning of this PowerPoint, the equation x minus mu divided by sigma equals Z, you can solve for x, and x is going to be equal to the mu plus Z times standard deviation. So in this case, 69.5 plus our Z for 95% there is 1.645, and then standard deviation in this case is 2.4, so 73.448 inches. So that is the approach that you would take if you're not using Excel, but that's not us. In this class with our Excel, we can do this a completely different way. So let me go back and we'll go with these cases right here and start looking at how it is that you can use Excel to answer these questions. Now, before we dive right in, I wanted to just say, if we have the X, the mean, and the standard deviation, we can calculate the Z-score. In this case, the percentage of women who have a height of 70 inches, we're trying to figure out, if 70 inches with a mean of 63.8 and the standard deviation is 2.6, what is the Z-score of 70 inches? Well, that's equal to, in the numerator, that's X minus the mean, close those parentheses because we're going to divide by, I want that right there. Let's get that out of the way. Hold on. Divide by standard deviation, which is C2. I don't want C4, I want C2. Boom. Okay. So you can see that this has a Z-score of 2.3846, or just 2.38. You can see that we calculated our Z-score by taking X minus the mean divided by the standard deviation. And so 70 inches has a z-score of 2.3846. Now we're trying to figure out what percentage of the women have a height of 70 inches or more. If we go to the next slide, here's just a reminder of what the equations are that we can use. And of 70 inches or more, we can put in either our x, our mean, and our standard deviation using the norm dist function. X, mean, standard deviation, and we want to say true because we're looking at the cumulative distribution function. We're not looking at a probability mass function in this case, so true is what I meant to say. Okay. Boom. 99.145. Remember, we were talking about this in when we were working through this problem in the PowerPoint. That's the area to the left, but in this case of the problem, we're trying to figure out what percentage of the women have a height of 70 inches or more. So we're going to say 1 minus this percentage that Excel gave us. You always have to write that as an equation. 1 minus this. If we convert this over to percents, let's give ourselves a decimal point. Write that as a percent and get a decimal point. I give it 2 decimal points here. You see that. There you go. So these are the values that Excel gives you. So what this tells us is that 0.85% of the women are going to have a height of 70 inches or more. And again, we used the norm dist function on this one as well. Since we've calculated the z-score, let me show you how it is that you can use the norm.s.dist function. Instead of those three, if we stick in the z-score, it's going to look like this. Norm.s.dist, and all it needs here is the z-score, and I'm just going to say pick it right out of here, and cumulative is true. Boom. And it's the same value. Okay. And so it's going to give you the same result. 0.85% of the women have a height of 70 inches or more. Okay. In this case, we use norm dist, and so we had to put in the 3 individual values. In the second case, we used norm.s.dist, and so we were just able to put in the z-score. Okay, gives you the same result, which hopefully you expected since both of those functions return x value. Okay, let us go on down to the second question. We want to figure out the percentage of women who have a height of 60 inches or less. So in this case, we're looking for 60 inches, and again, the mean is 63.8. The standard deviation is 2.6, and we could just copy this function down and calculate the z-score. Did we expect that to be negative? You bet, because we expected that to be negative because 60 is on the left side of the mean. 60 is 3.8 below the mean. 3.8 below the standard deviation is 2.6. So yeah, it's more than 1 standard deviation below the mean. Now, if I were to go ahead and calculate the norm dist function for this, I went ahead and did it up here. if I just copy that and paste it down here, that's given me just, 7.19%. That's the norm dist function using 60, 63.8, and 2.6 for our x, mean, and standard deviation. Now, does that make sense? Is that the answer we're looking for? Are we looking for 7.19? Remember, this function gives you the cumulative probability from the left, and what we were asking for is the percentage of women who have a height of 60 inches or less. So we're looking at the area to the left of the value of 60. So that is your answer right there. That's what we're looking for the second question. I'll go ahead and highlight. This is the answer for the first one. This is the answer for the second one. It's 7.19% of the women. If in this case, with women having a mean of 63.8 and a standard deviation of 2.6 for their height. Let's go on to the third one. The percentage of women who have a height between 62 and 65. Well, if we figure out the norm dist for 62, using these same values, we don't need the z-score if we're just going to use the function norm dist. Okay, I'm going to copy that, put it down here, V. Okay, that's 22.44%. That's the area. That's the area to the left of 62. Let's go ahead and put in 65. 65 with a mean of 63.8 and a standard deviation of 2.6. In that case, the area or the percentage of the women who have a height less than 65 is 67.78. So 24.44% of the women have a height less than 62. 67.78 of the women have a height less than 65. We're trying to figure out what percent of the women are between 62 and 65. From 62 to 65, that's going to be the difference between 67.78 and 24.44. If we just go ahead and do that, equals 67.78 minus 24.44. There you have it. That is the percentage of the women whose height is between 62 and 65. To figure out the height of the women, or the percentage of the women between those two numbers, we just calculated the difference. Okay? And then finally down here, we want to calculate the height range for the middle 60%. I want to figure out what's the height of the women who are somewhere between the 20th percentile and the 80th percentile. This takes us to this equation right here, because we're going to be looking at from the 20th percentile to the 80th percentile with our mean of 63.8 and our standard deviation of 2.6. And see, that returns an x value. So since we're looking for percentile, that's going to be the probability to the left of a particular x value, so we can find out what that is. So norm.inverse is our function. So here we go. We can we'll just jump over here and say, all right, a norm dot, oops, I need to put equals, don't I? Equals norm dot inverse. And this is Excel, it's really nice. We want to first of all figure out what value of of height. What's the X value with 20% of the data to the left? So I'm going to just put 0.2, and we know the mean is 63.8, and the standard deviation is 2.6. Okay, and that is all we need. So this is going to return the X value where 20% of the women are shorter, or 20% of the women are below this particular height. And so that's 61.6 inches. Okay, I'll double click on that so you can see that. Norm inverse, 20%, the mean of 63.8, standard deviation of 2.6. And then we want to also figure out what's the height of the 80th percentile. What's the height so that 80% of the women's height is below this particular X value. So we're going to go back to the same thing, norm inverse. And again, it starts out with the probability, then the mean, which is 63.8, and the standard deviation, which is 2.6. Close that up, and that is 65.9822. If we take that down to one decimal place, that's just going to be 66.0. Okay. So the middle 60%, so the 20th percentile to the 80th percentile goes from 61.6 inches up to 66 inches. According to this data, any woman whose height is in that range, they're in the middle 60% of all women. Okay, and I think, if you think about it, what's right halfway between 66 and 61.6? Right in the middle of that is 63.8. Okay, 63.8 is exactly halfway. So we've got 40% on the lower side of the mean, 40% on the upper side of the mean. That's the range for 30%. 30% below the mean of 63.8, and then from 63.8 up to 66, that's the 30% on the upper side of the mean. Okay. I hope that going through these 4 different questions, hope that helps you understand how it is that you use these 3 different functions. These are the same functions that we saw back in the previous section. It's just that in this case, we're talking about the standard normal distribution, where everything you can convert everything over to the z-score and think about z-scores instead of x's. But with our Excel, you can use the x value or you can use the z. However, if you're using a textbook, you have to convert everything over to z-score if you're going to use the standard normal distribution table that you find in the back of every statistics textbook. Okay, so take a look at this PowerPoint. You can read through it on your own, giving you several examples between the height of men and aircraft cabin, and these 4 cases here with the height of women. You've got 5 different examples to learn from, and each of those 5 can be solved using Microsoft Excel. All right. Hope that all helps. Hope that if you have any questions, be sure to ask me. I'll be happy to respond if you send me an email through Ask the Professor in Pearson. All right.